So we're talking about thermochemistry here. Thermochemistry is the study of energy in chemical reactions. You guys realize this because we just spent the past 2 days doing energy transformations with that lab. Technically speaking, most of what we study in chemistry is going to be the heat that's given off of a reaction, though. So we're talking about the thermal energy. Okay. As far as we talk about heat in this class, heat is a transfer of thermal energy between two bodies that are at different temperatures. Something interesting about a heat. Heat always flows from a warmer substance to a cooler object. So if you've been doing a lot of shoveling with this polar vortex and you go outside and you've been saying, wow, out there it's really cold and it's made me really cold, you're wrong. You made the outdoors warmer from a chemistry standpoint. Okay, so we always think about the heat flowing from the warmer object to the colder object. So you guys are contributing to global warming. Good job. Okay. Technically, yes, you made yourself colder. By giving your heat to the out of doors, you made yourself colder. You had that choice. The word temperature is going to be used as a measure of the amount of thermal energy, not a measure of heat itself. Okay. There's a slight difference between those two. Let me see if I can try and pinpoint why. Okay, here. Let's talk about this. It's about 20 degrees Celsius in here. It's actually a little bit warmer, but I'm going to use 20 because it's a nice round number. Okay. 20 degrees Celsius in here. How much more energy would the air have if we were at 40 degrees Celsius? Just to figure it out. It sounds like it's going to be twice as much because the number is twice as big, right? But the Celsius scale is based off of 0 being the freezing point of water. Do molecules still have energy at 0 degrees Celsius? Yeah, they still got energy. When do molecules stop having energy? All the way at 0 Kelvin, which is like negative 273 Celsius. So saying that 20 degrees Celsius and 40 degrees Celsius, it's twice the temperature, but it's not twice the amount of energy. Because the Celsius scale doesn't start with 0 being 0 energy. Okay, it starts way higher. Does that make a little sense to you guys? No? Okay. All right, I'll have to try and come up with a visual for tomorrow. Okay. All right. So, trying to push forward just so you guys can do this lab quickly. All right. Thermochemistry is the study of heat changes in a chemical reaction. Okay. And there's 2 key terms here that are important to talk about. One of them is the system, and the other is the surroundings. These 2 things are going to cause you some anxiety on the test, some difficulty. Okay, I'm going to try and make this easier. The system, by definition, is the specific part of the universe that is of interest in the study. And the surroundings, the definition is everything else in the universe. Hopefully I can get this to work well. Let's see. I don't know if I can get it. Can you read that? 17.6? Oh yeah, it is upside down. Okay. I don't think I have control over that. All right, so I don't have control over that. You guys are gonna have to trust me on this. It's upside down, but it says 17.8 degrees, 17.9 degrees. I can barely blur. It's a little bit blurry. I can see it on the screen. All right. So here's what I'm going to have to do. I'm going to take some sodium hydroxide. I am going to add it in here. It's not terribly good. As long as I sodium hydroxide is strong. What was the temperature before? 17.6 in Celsius. And I'll leave it in Celsius. Right now, this, no, ice is 0 degrees Celsius. Oh, right. Okay, can you read that? 18%. So, what happened? Sure, what? Okay. Recording. Okay. So here's the question. What was the system in this reaction? The sodium hydroxide, right? The sodium hydroxide is the chemicals that were doing the reacting. What's the surroundings in the reaction? The water, other surroundings. Everything else, the thermometer itself, the beaker, the air around the beaker, my hand. Okay, we could go farther out, right? The water. Okay, because the water wasn't actually doing the reacting. Okay, so the reaction, and I'm going to write this down on the slide here. The actual reaction that was happening was sodium hydroxide, solid, was being dissolved and dissociated into sodium and hydroxide. So what actually reacted? What actually changed in that chemical reaction? The sodium hydroxide. Did the water change? No. The water was facilitating the change, but it wasn't actually what was changing. Okay. So the idea here is this. Where's that thing? The chemicals that are actually doing the reacting are what are defined as the system. And the surroundings wind up being everything else that's around those chemicals. Okay. Now, there are two classifications of reactions that involve energy, that involve heat. One is called exothermic, the other is called endothermic. Okay. Exothermic is going to be any process that releases heat or that gives off heat. It winds up transferring thermal energy from the system into the surroundings. What just happened in that reaction that I just did? Sodium hydroxide got added to water. What happened to the surroundings? They got warmer, right? The thermometer read that the water was warmer. So that particular reaction, was it exothermic or was it the other one? It was exothermic because it increased the temperature. Okay. So there's a couple of ways that we can write this. Basically, one way that we can tell is that, notice, oh, my arrows are missing. Let me put these arrows in for the reaction. Apparently I had to click the mouse here. Okay. So notice that energy is written on the right side of the reaction when we have an exothermic process. Okay, that's because the energy is being created, being transferred from chemical energy into thermal energy. I shouldn't say created, should I? So the reaction should look like this because it gave off some energy. And that energy is the heat energy that we were able to see through the thermometer. And the other kind of reaction is called endothermic. Endothermic processes are one where heat has to be supplied to the system before the reaction happens. Or another way to look at it is that it's one where heat will be absorbed from the surroundings. The surroundings will actually get colder because heat is going to be sucked from them. the outside air making you colder is endothermic from that perspective. So one example here. Question is this going to be an endothermic or an exothermic reaction? Start out hot, put some salt in, and it winds up cold. Endothermic. Why is that? Heat's being taken away from the surroundings. The water is going to be surroundings here. Okay.